Okay, so today we're going to be running the two types of toner we've been sent. We have support toner, which is right here, and part toner, which are those 4 bottles. The rate here is between 3 and 10 kilograms per hour. That's relatively low for us. Additionally, it's not easy to get a good look in here right now, but it is fairly free-flowing from what we can tell so far. A little bit dusty, but that shouldn't be that much of a problem. And we have the glass vials right here that we're going to collect samples from. So how I'm going to do this is I'm going to dump 2 bottles at a time of one of the toner, and we're going to run it once, and then I will collect samples from there. And then if we have any tweaks to make the system, we will do that and run it again with the extra 2 bottles, but that might not even be necessary. Then for the unit, I have to apologize, we're not in our usual mezzanine spot. The vertical would be far too high for this application, so to sort of emulate your equipment, we are using a stand that we have in-house. This is about 8 feet high on the vertical, a little bit more than that, but around down to 8. And then on the horizontal, we also have about 8 feet. So we have our piFLOW P64 unit up there, and we have a discharge transition down to 3-inch triclover. We just figured the smaller the better, just to see if we could. And we just have some hose leading into a bag for collection. And instead of using a full feed hopper, we're just using the small cone module on the bottom. We don't think we'll need that much volume for this test specifically, but for the full-size feed station, if you plan on storing a bunch at a time, that would be better. But for this, we're just going to use the small feed station. Alright, so just to note the dust, we're going to dump the first bottle in now so we can see how that goes. Actually seems to do pretty well. There's definitely some dust forming though, but like we were discussing of that cover earlier, that would pretty much solve this problem. I would also note that we have fluidization nozzles and tubing on this feed station, but I am not going to use it at first because just based off of what we're viewing, I don't think we need it, and that would save us some money in the long run. So if we can do it without, that'd be great, but if we need it, I will turn that on. Alright, so I walked it back a little bit. We actually did include a module here just in case we get some dust pluming when we start the conveyor. But this is 2 bottles of support toner, and we are ready to go. So we have oh, there's the pluming, yep. So we have a 2-second suction time going right now, just because our capacity is only 2 liters. You can kind of see product going through the product line, but on the discharge, it is coming out pretty smoothly. Not much per cycle, but that is okay. We are seeing a little bit of rat holing action. Yeah, it's getting a little bit stubborn on the edges. So, almost done with that batch. Very hard to see through the bag at this point, but at the very least the discharge does seem to be going very smoothly. Not much in that cycle. And we're basically done with that batch. Obviously that problem wouldn't be as accentuated if you were constantly refilling the hopper, because you'd have more and more material to push down on that edge. So the more you refill it, the better that would go. But once you get down to those bottom segments, then that's where fluidization might come in handy. But we're going to finish up with this batch, make sure it all goes through. Then we will weigh out the bag, make sure it's that full 3 kilograms, and we will collect samples from this batch. Okay, so that was the first batch of support toner. We conveyed 6.4 pounds. Didn't time it, but if that requirement was per hour, that was definitely less than a full hour. So here's our bag. Obviously the weight of the bag is incorporated into this, so we did lose some product along the way, and I will show you where. we added this muffler on the aspiration points because we knew this was super dusty. We expected it. This was completely white when we put it on, so clearly it is getting through there. That was useful, so I could provide that for you guys. But also, we had to physically agitate some of the stuff to get it into the feed point, but even then, you can still see some toner still at the bottom there. It's hard to get around that. Fluidization wouldn't really affect the very bottom right there. So for our purposes, when we're using the same conveyor, we might get some cross-contamination, especially on the next batch of part toner. So the samples, you know, they might be a little bit cross-contaminated. But if we go with our system that we were discussing with 2 conveyors and 2 feed stations per application, then obviously that wouldn't be an issue. But we're going to put that last batch into some glass vials and ship them off to you guys when we are done. Okay, so we got our first batch of support toner. I am just going to fill up these vials as best as I can. Okay, so that's pretty good. I'm sure you guys know this already, but you know, just by looking at the bag, this stuff seems to apply a thin layer of itself over everything it touches in the gloves. Again, if we have 2 separate systems of 2 distinct conveyors and feed stations, this will not be a problem. But just something to note for future cleaning and otherwise maintenance purposes. Alright, so we are filling up the part toner into our feed hopper now. We got our 3 samples from the support toner. This leftover product right here, we're going to just throw away because it's already went through the system. And based off that test, I don't think we need to run it again. It's really just a matter of whether you think you need fluidization or not. You know, if you have people manually filling these bottles, you know, coming over to hook them into the sliding door, just have them give it a few taps on the side. Or if you have a viewport in the cover that we're going to design, you know, you could see how it's doing. If you need to take off the cover and physically agitate it yourself, you know, this stuff really is not terrible flowing whatsoever. It's quite good. So we're gonna do the same exact thing with our part toner. Same process, same everything, and see how it goes. So we got our part toner in, again, extremely dusty, just like the last time. They are overall pretty similar. This one might be a little bit lighter in color, but that's really all we can tell at the moment. So we're going to run with the same timers. There it is, pluming again. This stuff actually does seem to be falling a little bit better into the actual feed point. Okay, a little bit hard to see the discharge, but rest assured it is coming out. You can see the hose moving as the product goes through. Yeah, the toner is staining the bag, so it's a little bit difficult to see. But this is exactly what I was talking about. See how it gets a little caught on the edge right there? If we had feed station fluidization, it would be this big cone right here. We could fluidize the feed adapter itself, but you know that might solve this. But if it gets stuck in the very bottom there, but if you just give it a couple taps, on the bottom, continues to follow through. Really, any type of physical agitation will just knock it straight down in. We have to do this, but yeah, we have to do this because we're not constantly refilling. If you have people constantly putting these bottles in, then all this stuff would get pushed down by itself. So it's really up to you guys how much of an operator interaction you want, but really I don't think it would be completely necessary. Okay, so there's our batch of part toner. We have conveyed 6 pounds, minus the bag I believe that's 0.2 pounds, so roughly 5.8 pounds. Those part toner bottles were 1.25 kilograms rather than 1.5 kilograms of the support toner. So that was 2.5 that we put in, and we got out, you know, I'd say 90 to 95% of that stuff we lost, obviously sticking to the metal of the conveyor in the feed station. So, but that is pretty standard. Otherwise, we are going to take the samples from this batch and send those off to you guys. Alright, so here is our final samples that we took. We got 3 supports and 3 part vials. We only used 2 bottles of each type, so I will send back these 4 fresh bottles to you guys, but you know, we will keep this waste product. Like I said, there might be some cross-contamination, especially in the part vials, because we ran the support first. There might be traces of that in there. And also, like I was saying, we didn't even necessarily time these runs. I will check when I'm editing this video to see how long we truly were conveying, but realistically it was only, you know, a few minutes to convey 2 bottles of each type. But I will run those numbers, we'll get an actual expected rate, and then you guys can decide what you want to do from there.